Okay, so this lecture is meant to introduce you to some particular types of forces that we are going to be using quite a bit, okay? So the first force that we're going to look at almost every single situation is the idea of weight. And so this is the gravitational force. An object experiences due to a really large object. And for our purposes, that large object is Earth. We will go into kind of the nuances of how is that gravitational force different on different planets. But for right now, we're just looking at what is here on the Earth. The symbol we are going to utilize this is F sub g, gravitational force. The equation for it is that Fg is equal to mg, mass times gravity, where gravity is, or this g value is 9.8 meters per second squared. Notice we have a difference between g and ay. So recall, like in our kinematics equations, we would call it ay, and it would be negative 9.8 meters per second squared. When we're dealing with forces, we're just going to say 9.8, and the reason is when we do our force diagram, we're going to always indicate that this weight vector is pointing downwards, and that takes into account that negative direction value. So we don't need to include it doubly in our equation if we already are going to have it pointing down. We will talk about where this 9.8 comes from in a later unit. So for now, you just, again, have to believe me that the weight due to gravity here on Earth is due to this 9.8. And then the units, as with all forces, the units are newtons, and that newtons is comprised of kilograms times meters per second squared. So there's the weight. The next type of force is friction. Oh, and one thing with the weight force, weight is a field force. It is one of the few field forces that we are going to kind of think about, talk about, but it is a field force. It's due to a gravitational field of the planet. Friction, on the other hand, is a contact force. This is a contact force that hinders motion. It's kind of a generic term of it. We will definitely go into more detail with friction a little bit later on in the chapter. But right now we're just kind of thinking about this idea that it hinders movement, and this can be a surface friction or it could be a fluid friction. We'll dive into that a little bit more deeply in the next online lecture. The symbol for it is F sub little f. Okay, so this is the force of friction. We're not going to go into the equation of it right now. We're just going to conceptually look at this idea of friction. The next force is called the normal force. And this is a support force that an object experiences when it is touching another object. So this one is a little bit more abstract, but the normal force is, let me do the symbol first, and then I'll do a little diagram. The symbol is F sub n. And in order to kind of diagram it out with a force diagram, let's say I've got like a box, and it has like some kind of a mass. If we were to kind of think about the forces acting on just this box, we would say that it has an Fg, a weight pulling it down, our force gravity pulling it up, but it also has a normal force from the floor. So the floor is what's supporting it. The floor is what is preventing it from going into the floor. Okay, we want to break through. Okay. So that is the normal force. The normal force does not have an equation. It is just going to match whatever force it's countering. So in this case, it would just match the force of gravity, unless it couldn't match it anymore, unless the force of gravity was so big that the floor could not support it. It would match it until that point, and then it would fall through the floor. Okay? And I will go over another kind of conceptual example of this when we get back to class. And then the last force that I want to introduce you to is tension. And tension is a force that is exerted due to a string or a rope. It's a concept where it's like a pull force. And the symbol for this is F sub T. So hopefully you're kind of seeing the pattern in terms of how we are symbolizing our forces. It's F, and then typically the subscript here is the name of the force there. Tension is a lot like normal force in that there is no equation for tension. The rope is just going to match whatever the pull is, unless the rope cannot match it any longer, and then the rope would break. Okay? And we will see how tension and normal force are actually going to be understood better once you understand Newton's third law, which is going to be the next online lecture.